Hello team. In this video, we're going to talk briefly about handling complexity in cloud-native applications. So there are many sources of complexity in cloud systems. For example, we use a large number of technologies and tools. We have many different frameworks like we've seen Spark, MapReduce, can use third-party services like orchestration technologies like Argo CD. We have libraries like scikit-learn that we used. So there are many different sources that we combine when building applications. And in the cloud, we also have multiple layers of virtualization. So we have virtual networks, we have virtual storage, we have virtual machines, we have containers, which is one form of virtualization, and these are stacked on one another. So they also build complexity. And finally, the systems we build, they are more dynamic in the cloud. Most of them have auto-scaling, and we use continuous delivery. So these technologies make it so our services are in constant flux, changing all the time. And applications built for the cloud usually turn into distributed systems, particularly applications built around microservices. Distributed systems are intrinsically complex. For example, we will need to deal with replicated data, and we need to keep this data consistent across all the nodes in our distributed system. For example, consider the image processing application we had in the beginning. So you need to make sure that changes to the image are kept consistent across different filters and different microservices. We also have many possible interactions between the different systems or microservices that we build. And the combinations of sequences of interactions grow exponentially. And it may be that a bug only happens after a sequence of events. So because we have many sequences, it might be hard to identify a problem. And a bug might not only depend on the sequence of events, but also on when things happen. So we have random delays in the cloud, for example, communication delays and queuing delays and disk read and write delays. So many different delays. And these might impact system behavior in totally unpredictable ways. So it's very hard and usually impossible to reproduce these issues consistently. So we might observe a bug that happened once. Then because we can't generate this bug again to try to understand a little bit better what's going on, it's very hard to troubleshoot. And also in distributed systems, we have the potential for deadlocks, which is when a circular set of dependencies block all services. So one service depends on the other, and then no service can make any progress, and all of them just get stuck, and then the system stops working. So this also can happen in a distributed system. So how do we deal with this complexity? How do we build a trustworthy system? So we've talked about this throughout the course. One thing that we can do is build prototypes. And building a prototype, which is like a demo version of our system, like a simplified version, so we make some simplifying assumptions, but we build, a proof of concept. This helps us get insight into the possible architectures and also what are the main design decisions that we have to take when building the real system. And a prototype also allows us to test integrations with libraries, frameworks, and third-party services. We can also use analytical models. An analytical model is a theoretical formulation, usually with some simplifications as well, that helps us reason about a system. And if we have an analytical model, we might also get some insights into the properties of a system because these analytical tools usually come with these inference mechanisms. So we get some properties of the system once we put the analytical model in. One thing we can do is have extensive automated testing so that we test all the changes we make. We can also use continuous integration to make sure that the tests are run automatically whenever we change the code. And we can have continuous delivery so that if something breaks, we can roll back to the previous version so that the system keeps working. So all of these are example mechanisms, technologies, and practices that we can use to build a trustworthy system in the cloud.